Okay, welcome to today's lecture. Good to see you all here. Slightly fewer than yesterday. I guess people really needed to come to the first lecture, and then, well, I guess people are busy. That's okay, or late. Today, I'm going to talk mostly about the context of software architecture, like where it fits into everything. I think it's important to understand because there's this drive now these days, like, oh, architecture is not so important. Like there's the whole, I will come back to that later, but the whole design on a napkin kind of thing, which I will address in this lecture as well. Okay, just to recap, so yesterday we talked about the course introduction. I told you about the assignments and so on. Any questions about that so far? Like, has anything arisen apart from some people not being able to access Canvas and so on? Everything's clear? Good. Anyone still looking for a group apart from Skellefteå? Oh, excellent. Welcome. I just came from a lecture downtown by Jennifer Bullard, who's here, who's going to give a lecture tomorrow. And just to raise her up a little bit, so she is basically the coordinator for all the gaming companies, and they have a group where they support each other and so on, like the different gaming companies in Austin, Texas, and she's kind of like the chief of that group. So if you need to get in touch with anyone within gaming in Austin, Texas, you talk to her. So she's kind of like an important person, and she has lots of experience with being a manager in gaming companies, being like running a few startups, and she's in a startup right now and so on. So she's very, very skilled in when it comes to personnel management, requirements gathering, and all those things. And she will be talking about requirements gathering and asking feedback and getting feedback and things like that. I think it's very relevant to this course. But of course, if you have other questions outside of that topic, I don't think she minds if you ask them, like gaming and related things and whatever. So I think that'll be a good lecture. So that's tomorrow. Okay, I'm coming back to this image. I will show this quite a few times throughout the course. The reason why I'm coming back to this image is, well, software engineering. Software engineering covers requirements. You gather requirements. That's what you did in last course. You do a design, you implement it, you test it, and then you go back and, well, there's actually, in some of these diagrams, there's a maintenance part as well. So that is software engineering in a nutshell. And I think it's important to remember these phases. Even if you do a small project, you're still going to do, even if it's in your own head, you're going to go, okay, what is it I want to achieve? What's my program about? What's my application? And you might try to figure out some features. What do I actually need to implement? There is, of course, the whole, I'll do it while I program, like I'll add some features, and that's when you never finish. Like, oh, I just want to add that feature, and then people say, well, when are you going to sell this product? No, I'm not really done yet. So that's the other way of doing it. But even so, when you start programming, you try to think about like some form of structures, or if you don't, it's going to be very, very difficult to have a full understanding of what your software is about, and bringing in another developer and so on, it might be difficult. So yeah, I'm going to tell you this lecture how software architecture fits within this circle, within the different parts of it. I think software architecture is fundamental to software engineering in general. So we already covered some of the tools, some of the design tools, how to visualize things. To go into depth, the next step is like thinking how to do good programming, how to do good design. So the aim of this lecture is basically, what's affected by it? What questions do you ask yourself? So, starting with design. So we'll start at this arrow here, okay? when we think about design, we might think about different UML diagrams and so on. And those who took the project course, I told you about the module diagrams. You were asked to make one. They might look different. But this is a module diagram. So we have an applications layer. We have some core modules, and we have low-level modules. We have some connections between those. So yeah, this is a design. And what I would like to emphasize with this diagram is that a software architecture is more than just a diagram. There might not even be a diagram. Software architecture is the idea and the structure behind everything. So if you look at the model diagram, what does it rule? Well, for once, what are the responsibilities of each module? That's a question you need to ask. Like, what happens in this module? What should you solve? And then if the developer takes some freedom and does their own thing, at least they should try and stick within that module. And we're talking about cohesion again, like making sure one class does only one thing in order for readability and so on. Same goes with modules, like keeping things together, making it easy to understand and read the code. What can access what things? Like, what connections are there between different modules? What elements are there? How do they fit together? What kind of dependencies are there? And what are the relationships? So these are some of the basic questions we can ask just from a module diagram, which if we don't ask them, it's just a picture and nobody cares about the picture. Like the developers, it's just, I don't care. But if you start asking those questions, if someone actually puts some thought into asking, what are the responsibilities? What should this module contain? How should it be accessed? By whom? Etc. Going on further, we can look at the component and connector structure. So it's another type of diagram, another type of design. Not sure if you've seen those. Some of you probably have. So this is kind of like you have internal instruction component, you have different ports, you have required interfaces, that symbol. So they are standardized symbols for everything as well, of course. I will probably go through some of them that you can use, but people make up their own as well, which is fine. We have some database access here somewhere as well. But looking at this thing, yes, this is a diagram, but if we start asking the questions, we can start asking, okay, so what are the major executing components and how do they interact at runtime? You can start seeing like a flow here. You can see a connection between the search engine and the inventory and how they access things and how it runs on runtime. You can see the major shared data stores, like where is the data located, what files, do we have a security layer in place? Can this be accessed by anyone or just certain people? Do we have any user access control, etc.? So that can be looked at. That is the question that can be answered by good architecture. But if you neglect the architecture, people will make stuff up, right? Or forget about it. Especially if you have a lot of developers. A common mistake or problem is that, oh, it's someone else's problem. I've just been given this task here, right? And someone else will fix that, and nobody does, because everyone's focused on their own thing, and the only one who has the overall picture is the architect or whomever they talk to. So the architecture is important in that sense. And then if you only have your Hello World program, of course, everything scales, right? So if it's a very simple program, it's going to be a very simple architecture. The more complex it is, the more need there is for an architecture or some form of design method or design structure or thought behind it, guidelines, etc. As I mentioned yesterday, last year there was a group who had their implementation rejected just because it didn't follow the style of the rest of the program, even if the feature worked. So that's a guideline. Like, we program in this style because that's the way we try to communicate our design. So that is also part of an architecture. Class names, the way you locate them, which modules they're located in, and so on. So this component and connected structure as well will show you the progress throughout the system, what can run in parallel. That can be very, very tricky to do without some form of specification or guideline, or someone needs to think about that. Because otherwise you'll have racing conditions, you're going to have mismatched answers, etc., etc. Well, if you have one person, one developer doing all of the classes in that module, they can of course make their own solution within that module. But as soon as you're going to have access by some other part of the program being developed by some other person, suddenly you need to communicate how things work between, right? Otherwise, you're going to have problems. Okay, it also models like the dynamic behavior, what happens with the changes at runtime, and so on. There are another kind of design allocation structure. It's something we do at the university quite a lot because we have such diverse projects with so many different partners. And primarily is the last one here. What software elements are assigned to which team? So that is an allocation structure just based on, so France, they want to do image recognition. Okay, so they'll do all the image recognition stuff. How do we make a design that allows them to develop that independently and test it independently and then integrate it with the rest of the software? That is tricky, I'll tell you, because often you want to do reuse, right, of some part of the code. So if image recognition happens somewhere else in the software, they are reliant suddenly on the French team who have their own development schedule, and they don't plan to release anything until the last day or 2 weeks after the last day usually. I'm not saying that's the French, it's all university partners basically. So that is, it's part of the design. It's part of the architectures or the software architect's work to figure things like that out. And what processor does the element execute on? If you have multi-cores, if you have distributed computing, cloud storage or cloud systems, service-oriented architectures might be running on different computers, etc. Where are things running? How are they stored? And based on this as well, you can start thinking about, okay, is that computer going to be powered? Is it backed up? There are lots and lots of questions that arise from just asking these questions, right? Where are files stored and located? Yeah. So I would like you now to have just a brief discussion, maybe 5 minutes or so, and Skellefteå, you can think for yourself, discuss amongst yourself. So 3 or 4 people or something like that, just to ask yourself, so outside of just writing a design, I'm just giving you some examples, but outside of that, what should be considered when designing a software architecture? What other aspects should be considered? And there are a lot more than the ones I already mentioned. That's why I can still ask you questions. And what is the role of the software architect? And finally, why is software architecture important? So please have a short discussion. Let's do 5 minutes or so. Okay? Okay, so we have any ideas? Anyone want to give any feedback on these questions? And there are no wrong answers. Anyone? Yes.
We thought for the first question, we should consider if the pieces are dependent on each other. So when we design a software architecture, we should take care if these components are dependent on each other. So we have to have a timeline.
Yeah. So okay, so there's actually 2 points there. So there's dependencies amongst modules, I guess. There's also dependencies amongst parts of the software, so you can figure out like a development schedule. Is that correct? Yeah. Yeah. So the timeline comes in there, like when should you develop what, and if you're going to have a mock-up, what are you supposed to test and when, and you make sure to develop things in a certain order in order to be able to actually have a mock-up, because it makes no sense in developing the image recognition without having developed the image capturing part, right? You need to develop those together in order to have a mock-up that works. You could potentially, I guess, give it standard images just to do image recognition. I guess that could be possible to test it. But typically when you want to do mock-up, you try to piece some things together. So that timeline can definitely, that's a good answer. Anyone else? Maintainable and readable, absolutely. That's definitely part of the design and architecture's work, being able to create maintainable code. And some developers will have such experience that they will do this automatically, at least their own code. But I think on an overall aspect, it's good to have that on like an architectural level as well, where you look at reusability and also like modifiability along the way, so you can update things with new technology. And if there are bugs along the way, how do you actually push out new updates once you have deployed the system, so you don't need to recall all the software. Definitely, that's definitely part of the design as well. Anything else? Efficiency? Yeah, absolutely. Developing things to make the software efficient. That's not only CPUs, clock cycles, but also resource efficient. It could be energy efficiency, using green energy, or cutting down the use of energy power consumption. It could be storage. It could be just to, because efficiency in terms of storage is very important in some cases, because backup is expensive. If you're going to have lots of drives and you're going to have to lock backup in a fire-safe vault and stuff like that. We have that in L2 here, which means certain things cost money, because they need to store things. So every now and then they do, I don't know if it's a tape backup anymore. It used to be, many years ago, it was tape backup. I don't know if that's still the case, but they have vaults and stuff for storing things for a while, I believe. Maybe they changed since last I checked. Maybe someone at Lud knows all these things, but anyways, absolutely. Anything else? Documentation. Yes, that's definitely, I think it's something that the software architect conveys or communicates, you need to document your code, but it's also the documentation on an architectural level, absolutely. Communicating what features are available, how are they structured, what code are, and this documentation, it's quite important, because of course the market people, they're going to start selling the software before it's done. They need to market it. How do they market it? Well, they look at the features and say, this game is going to have these features, or this software is going to be able to do these and these things, right? So that comes from the requirement specification and the software architecture. If you're going to sell the architecture or sell a framework, you definitely need to know how is the architecture structured. If you're going to sell it to a third-party company that's going to develop a service on top of your framework, they need to know what they're getting, and that's the architecture. They don't exactly care about the specific implementation. What they care about are the APIs and the structure, and how it's documented and communicated, and if it's maintainable, efficient, and all those things. And when you do your mock-ups, you document the mock-ups, you show it to the customer, and you have that timeline. You can do testing, you can do early testing and get early feedback based on how you document things as well. So yeah, absolutely. Anything else? Okay, I have, there's one thing that you kind of said, but it's been something I've said in the previous course a lot. On time within budget, remember that? I think it was like in every lecture. It's important, quality software on time within budget. If you create a good design, you can control the flow in a much better way. If you just do, oh, I'm just going to add a feature, I'm just going to add some things that I like. It's very difficult to say when are you going to be done. It's very difficult to schedule your software, right? If you have a plan, if you have a design, a plan, you start splitting the work between team members. You can set deadlines like this module, this little thing, should probably take 3 days to implement. And if it doesn't, then you know how much your schedule is skewed back and forth. If you just give someone, can you develop a software that does CSN payments? They're going to go, yeah, how long is that going to take? X weeks, you know? It's very difficult, but if you start splitting it up, it's much easier. Okay. So here are a number of points. I have 13 in total. Quality attributes. We covered some of them. Maintainability, efficiency. Those are quality attributes. Reusability are also one. Security, scalability. So yeah, by looking at design, we can control those. We can start developing or creating an architecture based on what quality attribute we prioritize. We can manage change as it evolves. Now there's going to be these people who complain about, well, there's no point in having an architecture because it's never updated. And yes, I understand where they're coming from, because if the architecture doesn't follow the implementation changes because there are meetings and so on. If it's not communicated, then the architecture soon becomes irrelevant, right? So there's a balance here, and in really large scale projects, they are very strict with architecture because they need to maintain that control. In larger or smaller projects, or more, like if you have a smaller development team, like Google has, they do small teams, then you can communicate architecture updates verbally. But they're still, like they try to maintain some form of joint understanding of how the design works and how it's structured. So it doesn't always have to be papers, you know? It can be some other form of communication. Early prediction of qualities, already mentioned. Enhanced communication among stakeholders. That's where the timeline comes in, by the way. If you want to show it to a potential customer or the marketing people or your boss, or if it's to show the end user, it might be the quality assurance person. I mean, there are lots and lots of stakeholders who have different types of interests, but by having a good design, that is a fundamental thing that you can use in such discussions. Yeah, so fundamental design decisions. Different constraints, and how that affects the implementations and so on. Structural organization. So this is how you can split code into different development teams by structuring your code, structuring your design in certain ways. You can make it easy to split, and that means you can split it. In a certain type of organization as well. Like there might be a expert development team on audio codecs in some place, and you can separate that part of the software and give them to them so they can work on it standalone, which helps a lot. Basis for evolutionary prototyping. Again, the timeline comes in. Trying to figure out when to test and what to test. Cost and schedule, already mentioned. If we have an architecture or a design, that can be something we can reuse, we can build upon it. If we're going to build version 2.0, we can look at the current architecture and see what's bad, what's missing, where are the bottlenecks, and we can make changes on top of that, right? So we can reuse, we can decide to reuse certain parts. Do you know the software Maritech? I probably used it as an example last time around as well. So it's the video conferencing software that was developed here in LTU that became Maritech. That was then bought by Google, and which is kind of Google Hangouts. The developers who developed Maritech also been part of developing Google Hangouts. So they had a part of their code that nobody touched because nobody knew how it worked, but it worked. So it was like this black box, and yeah, nobody touches that because we don't know how to fix it. So that is an example of like it's been developing over time, and the design has not been modified or updated. So nobody knows what's in there, but it works. That means whenever they wanted to update to include newer technologies, it would be like a big hassle. They wouldn't know what can we change, how if we do this, will it break? And basically they hindered themselves. By having a better code, they could have stayed more up to date, and changes and newer features would have been easier to implement, basically. Should look here. So, yeah, creativity. I mean, some people say, well, if I have a very fixed design, I will not be creative as an implementer. While I can kind of see where that point is coming from, I also argue that if you don't have a design, you don't know what freedoms you are allowed to take without breaking stuff, right? So if you know, as long as I adhere to this interface here, I can do whatever as long as I do these features, right? That means as a developer within your area that you've been assigned, you have a lot of freedom suddenly if you have the specification. If you don't know the other modules, how they're going to access your code or your part, then suddenly that freedom becomes a communication game where you have to, okay, what do you want to, what data do you want? And you start having to have this dialogue, which uses up a lot of time, and there might anyways be problems in the end because you don't have a specification. Specification actually helps creativity, I believe. But there's always this sort of overdoing it, of course. And if you have a new team member, having a good architecture makes it a lot easier for them to get started, basically. Okay, so that is the architect. I'm gonna show you a short video from Microsoft Research about the role of the architect. Have some, oops, wrong window.
Hi, I'm Brian Prince. Welcome to Bytes by MSDN. Today we have Yuval Lowy with us. Thanks for taking some time out at TechEd to visit with us. I know you're real busy here. You have 4 sessions?
Yeah, and a pre-con.
Yeah, so it's a lot of work, I know. So earlier we were talking about architects. You do a lot of, a leader in the architect community, I think, and thinking like that. What's the role of an architect these days?
That's a very interesting question, right? So I think that the architect is actually overloaded. It's actually evolved over the years. Mm-hmm. In the early years, early 90s, people didn't even have the title architect, right? If you were to go back in time and corner a team and say, who's your architect? They're going to say, Archie what?
Yeah.
I mean, at most you had like a technical lead team. But I think through the 90s, the term has evolved, mostly because the term software engineer is already occupied by what are fundamentally just developers, right? But what the architect needs to do is apply hardcore engineering principles and practices to software systems. It turns out that software is a highly malleable entity. You can design to be extended or be reused or highly specialized and be maintainable and somebody else to own it besides its original creator. These are all engineering questions, not different from the way a mechanical engineer designs a part, or a civil engineer designs a bridge, or someone designs an airplane wing or an engine. Mm-hmm. And you can absolutely do the same things in building a software system, complying with similar engineering principles. And so projects that do this kind of a thing prosper. Now, that's the one small definition, but if you think about it, architects today do far more than architecture. If you look at the time spent doing architecture, true architecture can only be done in cycles boundaries. When you're truly done with the system, you do the next system. So that happens every 3 to 5 years today when you're done with the system. And the boss is not going to give you more than a few weeks to work on it. I mean, if you like, it's going to be 3 weeks, 4 weeks, 5 weeks, 6 weeks. But the cycle is measured in years. So if the difference is weeks versus years, that's 52 to 1. Let's make it 50 to 1. You know, that's 2%. Yeah. So maybe you spend 3% of the time. So even if you spend 2% or 3% of your time on something, that's very misleading to call somebody an architect if only do is 3% architecture. So what do they do in the other 97% of the time? Well, that also has changed over the last 10 or 15 years. The role of the architect has evolved more than just be the technical lead or the architect. Today, they also have to take an active leadership role in process and in technology. The active leadership role in process means, at the end of the day, most managers don't really care about process, just want to have the thing getting out the door.
Just make it work.
Just make it work. Code like hell, here's a death march, let's do it, right? Yeah. Developers are spread too thin to actually care about process. So almost by elimination, the architect has to own the process and to take an active leadership role, making sure that all the key things required for success are actually done. The other thing is being a technical lead, but in a different way than what it was 15 or 20 years ago. 15, 20 years ago, a good technical lead showed developers how to do something. Today, nobody needs help with how to do. They just go to a search engine.
Bytes by MSDN, perhaps.
Maybe, and they type whatever they need, and they take the first hit and they copy and paste.
Oh, yeah.
They don't really value what it means, don't know what it is, and just, I call it voodoo programming. Copy, paste, you move on. Developers, in fact, have honed this skill of programming systems this way. Mm-hmm. Now, what developers desperately need help with is what to do. There's so many ways and options of doing pretty much anything today. So a good architect helps them with what to do, not necessarily with the how. The how they'll figure it out. Mm-hmm. Now, if somebody owns all technical aspects of the project and the design aspect of the project and the process aspect of the project, that somebody is, for all intent and purpose, the technical manager of the project. You don't manage the developers like a paper-pushing, pointy-haired, Dilbert-style manager, but you manage the technical aspect of the project. And that is the true functionality of the architect today.
Okay, so how do you become an architect? So that sounds like, you know, I might need some experience in my career. Probably not fresh out of college will I be an architect. How do I become an architect?
I have actually seen architects out of college, people that were blessed with built-in appreciation for good structure and aesthetics and elegance in software. Mm-hmm. But the thing is, hardly anybody would give somebody fresh out of college the opportunity to become an architect.
Okay, fair enough, yeah.
So I think it's kind of like if you have to ask the question, it's already too late, right? Because you have to be on a path. You have to actively manage your career. Nobody is going to take somebody who's employed as a developer and say, okay, now you are the architect. You have to do it before you get the title. You have to look for positions that are actively looking for an architect. If you think that you don't know everything and nobody does, right? Actively look at opportunities to study with somebody. Look for a master architect and become their apprentice for
a mentor.
A mentor, absolutely. These are all proactive things you have to do to grow your own career and become a great architect.
Yeah, so you're planning on putting on a seminar.
Okay, we'll stop there.
Conference.
Okay, so architecture, the architect, etc., it's more than just making design documents. We already established that it affects a lot of different areas, but it also becomes kind of a leadership role. Based on, as the architect, you have the overall understanding of what is to be achieved. It's kind of the communication between the requirements engineer, who might have gathered some requirements, towards the implementation, right? So having those skills, leadership skills, etc., it helps. So that's why in the previous course we talked a little bit about like this whole social aspect of software engineering, where like collaboration and working in a team, working in a group becomes an important aspect. Having that role and leadership on top of it. Oops, should I have this one? Okay, so just some fundamental understanding of so every application has an architecture. Whether that is on a document or in your head or verbally communicated, etc., it has an architecture. Whether it's good or bad, that's a different matter. It can be a very terrible architecture, but it has an architecture. Every application has at least one architecture, meaning that there might be different ideas of what the architecture is. Especially if it's just verbally communicated, but even if it's written down in the document, there might be developers who yeah, but I believe it's interpreted this way, or they have taken some liberties, or there's kind of yeah, but we've always done that way. Where they have experience, or they based it on a framework they used previously, etc. So yeah, it might have several different understanding of what architecture is, and architecture is not something you only do in the beginning. It is not one phase. It's something that continues throughout the project or throughout the development. What it is not, the wrong view. If you look at it only as a phase, then architecture becomes only that high-level document, that design, those UML diagrams, right? And we already established that it's not only the diagrams. It's more than that. It's also represented by the code, how things fit together, even the documentation of things, even the code documentation. So and there's going to be a lot of comments in the code structure that states updates to the architecture. I've even seen, I probably used as an example last year as well, but I worked with the development kits for the Bluetooth version 0.9 or something like that, very, very early versions by Ericsson. And I read the source code, and I have nightmares. But there you could see, in the comment section, you could see, okay, so this is a bug. I've done something different based on. I've ignored the architecture because it doesn't work, and I've done this instead. You could also see comments "Fuck this shit, I'm going home now." But that's another matter. So the documentation, the code is also part of it. It's architecture, and it needs to be communicated. And with that, I think we should have a break. So let's have a 5-minute break.
Jag kan se en ansökan till kursen. Jag har fortfarande öppen. Det tar ett par dagar innan man kommer in på platser.
Jo, ja, bara du har gått med studievägledaren och sådär så...
Nej, det är på antagning.
Okej. Du kan gå och prata med studievägledaren och sen processa lite snabbare och sådär. För jag får inte ta beslut.
Nej, det vet jag. Nej, det är ingen fara.
Nej, men det är bara lite för föreläsning så länge.
Ja, exakt.
Det gör inte mig någonting att du är här. Men,
nej, jag vet. Men
du kan prata med studievägledaren och säga att det är ett sväng på det.
Ja.
Och se om det, när det sker och när det händer.
Vad var det för projekt? Du hade snackat om det igår, eller?
Ja, de finns ju på Canvas-sidan som du får säkert inte ha tillgång till.
Nej, ja, men då får jag det sen.
Första assignmenten är typ hitta en grupp med 2-3 personer totalt och välj ut ett GitHub-projekt av en viss storlek som du vill jobba med, och då ska det första labben, alltså labb 1, det är ju assignment 0 av den här lilla gruppen.
Ja.
Assignment 1 är typ reverse engineer, alltså typ visa att du förstår hur allting hänger ihop, och då kan man välja en del av programmet.
Ja.
Assignment 2 hitta design patterns. Assignment 3 är en separat testingslabb. Assignment 4 är en change request i det projektet, alltså implementera en feature.
Ja.
Och assignment 5 är förbereda prestationen, och sen är det seminarier, och så är det assignment 6 hämta ett app.
Okej. Ja, bra.
Men hör av dig om du inte får tillgång till Canvas-rummet, så skickar jag det.
Are you going to share the slides?
They are on the Canvas room. The last year's slides are on the Canvas room, but I will put up the new version. The recorder is being recorded as well, so you can look at the recording. I will send that out as well. I den här kursen har vi typ bara den här och 109, och 109 är ju bättre än den här.
Är det 12?
Nej, det är 17. Den är tvärt över. Vi har i och för sig en sista i 18. Ja. Jag har ju skärmar här så jag kan se. Nu funkar inte de här, så jag ser bara video. Jag ser inte slide. Annars brukar man kunna sätta sådana slider också. Då kan man se ut som det jättemycket om man bara tittar aldrig på datorn och bara... Så det kan jag ha. Nej, då är vi barn i sånt där. Då skickar vi inte till rätter, då är det bara... Men vad man gör är att man sätter sin dator framför sig. ...20 seconds left. Okay, let's continue. So, we covered already now how software architecture affects design. I started with that because it's kind of self-explanatory, architecture, design, yeah. Let's continue now with requirements. How does software architecture affect requirements, and in what ways? Okay, so traditionally, before we understood the importance of architecture and design and so on, requirements analysis would have been done like first you go and ask the customer what they want, then based on what they say you make an architecture, right? And that's like what we did in the project course as well, kind of. Well, all the way you got to get a document first, kind of, but it's like step 1, step 2, step 3, and following this here very, very closely, like start with requirements analysis and go on. Thing is, there are better ways to do this. So without looking at existing architectures, looking at existing frameworks, middlewares, etc., the reusability suffers, right? I mean, you don't want to reinvent the wheel. And if you're a company, you might even have earlier versions or previous products. Or, I mean, if Microsoft never had a common code base, you wouldn't have like the Office family, because they share some things, right? The clipboard manager and stuff like that. So they base their requirement analysis together with architecture and design and what they have previously, because they would like to reuse things and yeah. So yeah, how can we do more requirements analysis more efficiently? Yeah, so the existing solutions that exist today, and not only the ones you have in your own company or your own frameworks and all middlewares, but also the way of designing, the way of thinking affects how you can ask, requirements and how to make a design later on. Because people learn a specific way to do things. Like all Android applications are supposed to look very similar. They should have the menu in certain ways. I mean, not all of them do, but there are design guidelines for certain things, right? Which affect what questions you ask, like what features you ask, the naming convention of certain buttons. There are rules for that. And it may follow certain design guidelines, and certain things you ask in terms of features might be affected by these design guidelines. So existing solutions, even if there are existing solutions in another domain, might affect how you design your software and what questions you ask during requirements gathering. So also our understanding of what works now and what doesn't work will of course affect what we want and what we need. As a customer, I know I've used this calendar application. I like those features. I would like to have those features, but I would also like to have this thing. We are affected by other things. And by looking at architecture and what's available, what's possible, and the customer might have, I want it to be cheap, but I would like to have these features. Okay, so what available things are there that we don't need to reinvent? And based on that, are they very similar to what's already there? Yeah, and our experience with existing system might help us imagine new features and what might work in the future. Helps us visualize trends and help us understand development cost and how long time it will take and so on, by looking at, do we need to start from scratch or is there something available? So that's why it's important to do these things in parallel and not just do phase 1, phase 2. If we can take existing things into design, existing architecture, existing frameworks, middleware, we can save time. We can make it better, we can improve quality, etc. What can happen if we do not consider these at the same time? Just have a quick question. Anyone have any idea? I have a very telling question, or telling picture. So here is the regal ship Vasa, which is famous in Sweden, for those of you who don't know. It's famous because our king, I'm not 100% certain of the story here, so you can correct me if you want, but our king wanted to have the greatest battleship ever. So he basically told the architect, add more cannons. And so he did, even though his knowledge about boats and ships and engineering told him this is probably not a good idea. But he ignored that because it was the king's decree. He needed more cannons. So the regal ship Vasa has some extra cannon decks. Now, when this ship was launched, they didn't strap the cannons in properly, and there was like a gust of wind or something, some waves, and the cannons slipped. And they had lots of weight on one side, and because regal ship Vasa is so tall, because they added more cannons and more decks to the ship, it tipped over and sunk on its maiden voyage. So here we have an architect who is experienced, who has experience of existing systems, existing designs, what works, who then ignores that because of king's decree. By not taking, during the requirements analysis, like the king said, more cannons. That's a requirement, right? The architect should have said, well, then we need to make the ship wider or something else. Based on what we are able to do now, it's not possible. So that, unfortunately, dear king, you cannot have more cannons, or you need to make some other kind of design based on our expertise of how ships work. So to solve this problem or this discrepancy between requirements and design and trying to do this iteratively, we can look at something called the Twin Peaks model. So what we do is we start small, like what are the basic features and what is available, and then we start evolving, and eventually we'll have a complete architecture and a complete requirements. And it's an iterative process. It's something we do continuously, and that's why architecture is not one phase. It's something that we need to do iteratively, because we come back to things, we realize, yeah, but this security layer we have here, why don't we just use OAuth 2? And we bring that in, and it's solved. Why don't we use this existing framework and put it in here? Or we realize that there's going to be a bottleneck, or we're going to have some reusability issues. Let's redesign it. And you try to evolve and make a better architecture out of it. So that is how software architecture affects requirements. I think I already covered design. Yeah, we already covered this. Yeah, for design, some things that I forgot to cover. Yeah, it might be translating certain algorithms, and we consider a lot of different stakeholders. I think we've covered most of them. Okay, so we come to an interesting thing then. Implementation, the next part of the phase. We had requirements, we had design, now the implementation. Okay, I'm going to read you a quote here from Zuckerberg, so that's the founder of Facebook, right? And so he wrote, we should not forget that ultimately it is all and only about the code. Hacking is also an inherently hands-on and active discipline. Instead of debating for days whether a new idea is possible or what the best way to build something is, hackers would rather just prototype something and see what works. There's a hacker mantra that you hear a lot around Facebook offices. Code wins argument. No code base I have worked on had any design documents that you can rely on to understand the architecture of the code. If it exists, it is out of date in less than a week. Anything artifact that does not break the build is not worth maintaining. The best skill students can learn is to dive into a giant code base and be up to speed quickly so they can contribute meaningfully. Now, this is from a GitHub page from the first year I taught this course, where one of the students quite early on said, I would like to grab this project. My teacher tells me that I have to do a change request. What do you think? And the owner of that project sent this back, basically. And rather than just ignoring it and saying, oh, I don't want to deal with this, I basically put it up on here on the slide and let's deal with it. So what do you think? Is this correct? Let's start first off. Does this person have a point? I see some nodding. Yeah, I agree. He has some points, and definitely I mean, Zuckerberg, he, Mark Zuckerberg, right? Yeah, Mark Zuckerberg, yeah. So Zuckerberg, he has a point in which, in Facebook, they probably had a history of people sitting in meetings arguing a lot. Like, can we add this feature? No, it will take too much time. We don't have the resources. Or when should we do that? And then suddenly some developer came. I don't care what you say. I did it. Here it is. It works. And they went, oh, okay, I guess we'll include it then. So I'm imagining that's what happened, you know? So the code wins arguments. Rather than sitting debating, can we do this? Shall we make a design? They delivered working code. I agree that's definitely efficient. I agree that in some cases it definitely works. And I definitely agree that this person has a point. Coming from like university where development is 90% paperwork, where specifications are tedious, and I showed you the requirement specification, like the 200-page documents and so on, and nobody reads them, right? They're out of date, they are irrelevant, and so on. I agree with this person when it comes to that kind of documentation. I definitely do. But I already stated before, which it's a statement I stand by, all implementations have an architecture, whether it's communicated or not, right? I think you can agree on that one because it's kind of a vague statement. Now, I know for a fact that this works in certain places, but not all places, because if I ask Försäkringskassan, for instance, I take them as an example because they're coming here, they will tell me that architecture is important because if there's a bug, Elsa, 70 years, doesn't get her pension. And it's a serious problem. And especially with these security systems and where the effect, I mean, if I use everyday thing, the effect of something going wrong is irritation. It's something we can deal with, but of course, if you're Facebook or Google, the irritation is multiplied by millions of people. So still, it's a big fallout. But if people's lives are involved, it suddenly becomes a little bit more serious. And I think that also when you have an architecture that is very modularized, where I will make this part of the application and it's standalone, it works, then architecture is not as important because that one person, as long as that person is a skilled developer, has experience in developing good code that is reusable and maintainable, etc., that person is then kind of his own architecture, his or her own architect. And they've developed something that they can then deliver that works. And if it's a standalone thing, it will plug into the rest of the system, right? If you have a very interconnected system, lots of connections, lots of dependencies, that becomes much harder. Would you agree on that? So the less or the fewer modules, the more interconnections, the more dependency, the more reusability and even efficiency or resource efficiency in this case, because often you have to make certain compromises in terms of readability just to make things more efficient. So in that case, it can be difficult to have this approach. So I will now make this statement, and so as much as I've preached architecture here, I can tell you that there are some cases I definitely agree that design on a napkin, don't spend too much time on design, it's okay. Because the overall architecture allows that kind of behavior. However, I also believe that as soon as you have lots of different developers that is going to work on your code, the more need there is for design. If you're alone, you can be responsible for yourself, but then also that company becomes dependent on you. And if you are then gone, who is your code then readable, understandable for other people? If you have lots of people, it's absolutely crucial to have a design if they're going to work with it. So that is my answer to this question. Would you agree or disagree with me? Okay, let's do, if you disagree, just go like that, because then you can. Okay, no serious disagreement. I think it's an important thing to cover, though, because I believe that many people, especially those who have some experience with professional development, are really sick and tired of lots of documentations, I myself included, because nobody reads it. So that is why the whole agile development thing has kind of arisen, because the whole documentation thing is part of this waterfall development process, and we went through that in the last course. But we have been preaching like agile development, and especially Scrum, as you did in the project course, in which you do a daily stand-up, right? What do you do in a stand-up? You talk architecture, you talk about bug fixes, what shall we supposed to do next? Those next things, the sprints, the sprint planning, those are features as part of an architecture, right? You are communicating it verbally. Do you agree? Okay. So that is part of a design. Someone has an overall picture of these features go into our application, and this is the order we should develop them in, and today you are doing that thing. And then tomorrow you report whether you developed it or not. A verbal communication, which is not hundreds of pages of paper. Still, it is a design. Yeah, so the purpose of course with an implementation is always to create machine executable code. I believe that the code should be faithful to the architecture, whether the architecture is communicated or not. And if the code is not faithful, then you should update the architecture. Because an architecture that is not up to date is useless, just as Zuckerberg says, right? I mean, it's no point, or actually, so as this poster says, I think it's head in the box. Yeah, so that's a guy in GitHub who wrote these other things. Yeah, so if it's not up to date, it's useless, and I agree. So either you make sure the code fits the architecture, or you make sure that the architecture fits the code, and you update that during your daily or weekly meetings, either verbally or on paper or whatever. If it's a very complicated software, there's going to be change requests, and there's going to be a very formal way of doing it, and there's a lot of paperwork involved, and that is because it has to be. Otherwise, you have no control over it. And of course, there are adaptations, or there are updates that you don't need to put in the architecture because the architecture itself is not detailed enough. Like, if you only have an architecture on a module level, what each class does is not important as long as the module itself does the same things. So it all depends on the granularity of things. Okay, so just some concepts here. Faithful implementation, it means that all the structural elements in the architecture are implemented. It means the source code does not utilize major new computational elements other than those specified in the architecture. So it also means that the source code does not have any new connections that have not been specified in the architecture either. So is this realistic? Well, I think that you should always communicate your architecture or the changes you do. I think in some cases, simply adding a note somewhere that is publicly available, or that, you know, the way you put things might be a good way to compromise, just to state somewhere, this code is not faithful to the architecture, these are the changes I've made. Because going into the code and trying to find that out will be very difficult. However, if there is like a README file somewhere in your module, people can go there and you can summarize all the things you've done differently. That is a lot better than not communicating at all. And that, I think, is reasonable. Would you agree? Unfaithful implementation. Yeah, so you have not followed all the specification. So you fail to recognize the distinction between planned and implemented architecture. It has consequences because suddenly the marketing people start promising a product that you cannot deliver because the features in your application are not the same as specified. The architecture is not the same as specified. And it's very difficult to reason about the architecture in the future. So if you're going to say, oh, let's extend our application or project by doing these features, and then you look at the code and realize, oh, but it'll take 3 extra weeks because what we implemented is not the architecture, it's something else, and it's not done the same way or by the same thought. And it's difficult to evolve, of course, as well. So different strategies. Of course, there are different generators for this. You can use middlewares from frameworks and so on in order to reuse things, in order to improve your architecture and so on. And of course, you can write everything manually. So going over to analysis and testing, and I have like 20 minutes left, right? Okay. How does software architecture come into play when you talk about analysis and testing? Of course, testing has to do with quality of an artifact. And the earlier you detect a problem, the easier it is to fix usually, and cheaper and so on. Which also means that if you can represent this, if you can convey the architecture, if you can present the design of the code, it's much easier to understand how things fit together, where the problem might be, and so on. So you can ask specific questions on, like, during the analysis phase, like where is the bottleneck, where do things go wrong, because you can look at an overall design document and so on. So if you have an architectural model, if it's communicated, it improves the consistency, it improves the way you can test, it improves the way you can find problems and solve problems or solve bugs. It helps you find mismatches in your code between what the implemented features are compared to what it's supposed to be. If there are any incomplete specification, any undecided communication pattern, like suddenly you realize, oh, why is this port open? You don't know. Okay, so you know what should be open based on the design, but suddenly you find something apart from that, and you need to track it down. It can help you solve and reduce deadlocks and so on if you have parallel processing, and of course the whole security area, which is very important. Like if during an analysis and testing, if the design and implementation is true to the architectural design, you know where to test for problems, and if it's not, you'll soon find that while doing security testing. Okay. So yeah, it is important for testing as well. And during your assignment 3, you will be getting these functional requirements. You'll get source code, and you get to test whether the implementation, the source code you get, is true to those requirements. And here, I mean, the requirements here are the design is communicated via code, but you get to like understand and see how it all fits together. So that's kind of a good example of this, I guess. And since there is like this find 5 faults or whatever in the second part of that assignment, you're going to see where they did something wrong based on testing and knowing the design. Okay, so let's just establish that we know that software is going to evolve, things are going to change. The nice design we created in the beginning is not going to be the same in the end because we are going to make updates. We're going to find flaws in it. We're going to make changes. So we keep it updated, and in terms of not being able to update the full document, we might write a note somewhere. We try to communicate it verbally. And we try to reduce this quality degradation of the architecture. So during the development process, and in general, like how software architecture is going through the entire process step by step. So we, marketing people or business people, they make a case for the system. Like they try to sell it to investors, they try to sell it to customers, they have pre-sales. And at that point, you need to understand what's significant, what are the requirements, how would we design such a software? And you create an architecture, that's step 3. You start documenting it, you start communicating this architecture. Of course, then after you start documenting it, you start analyzing it, whether it will fulfill the requirements that you promised in step 1. You start implementing it, you start testing it based on those requirements, based on the architecture, based on what you know about the system. And you make sure that it actually conforms to the architecture based on your tests. And the reason why we have these steps is because we have a lot of stakeholders and we have a lot of different steps that we need to go through, especially if you're going to make money of a software. And it all comes down to that, right? How much money will we make? And it's based on like stakeholder needs, business management issues, legal, contractual issues, commercial, competitive pressures, technical environment, political issues, lifecycle issues, and so on. And they all filter together to, well, do we have good requirements, business requirements, functional requirements, quality attributes? You create something and you try to create a system from that. And of course, not all the stakeholders are going to agree on everything. So the developing organization management stakeholder, they will want to have low costs, keeping people employed, making sure that the business will run. A marketing stakeholder, neat features, short time to market, low cost, parity with competing products. Yeah, the end user stakeholder, which look at behavior, performance, security, reliability, usability. And then you have the maintenance organization stakeholder, which look at modifiability, and the customer stakeholder, low cost, timely delivery, not changed very often, etc. Like all of this is something that the architect ends up having to battle with. So yeah, being a software architect is super easy. Or maybe not. But it's something you get better at. And I believe that even if you don't get the formal role as a software architect, as someone who's studied a master in computer science or like a master's degree, you probably end up at some point in kind of a leading position, I believe. Many of you will anyways. And you will eventually make choices or design decisions, even if it's not on an overall level, but maybe on just your module or whatever. And just knowing that you need to adhere to certain like requirements, not only from the customer, but from like all these other people, maintenance officer and stuff like that. And just a quick discussion, like, okay, so kind of business goals do you think have driven the construction of the World Wide Web and the Google Android platform? And what effect had that had on the construction of those architectures? Can we take like 3 or 4 minutes maybe? Okay, so what kind of business goals have driven the development or the construction of Google Android? Money, of course, and anything in particular in regards to like money in this case, because they have a market, right? Market shares and so on. So they want to compete with iOS primarily, right? And previously maybe knock off Symbian and Nokia Windows platform, right? So of course they needed to have better features than iOS. In this case, I think maybe what kind of design goals have that had? Like how has that affected the architecture? Before I give you my own interpretation of that.
I think one of the business components
Yeah, absolutely.
take market share.
Yeah, so yeah, bringing lots of companies together to have a bigger market share because iOS is just only Apple, right? Right. So there's a customizability aspect based on like if you run it on an HTC or a Samsung or whatever else, yeah? Absolutely. So it's built in to be customizable to your own platform, but still to have a common code base to run the same applications, right? Anything else? I think personally it has affected the way the whole Apple Store contra versus Android or Android Store has been affected. Like the way that they approve applications and how, I mean, Android being Java, only that, like, while iOS had their own kind of Object-C in the beginning, now it's Swift, but in the beginning, like, iOS was kind of the difficult, like, sophisticated, while the Android was easy to get started, like, just deploy more softwares, open for everyone can run whatever application they want on it, and you don't need to go via the Apple Store and forced into that kind of system. They wanted to keep it open, right? To compete with the masses, to have more applications early on. That's what I believe. And that is also part of keeping this platform open. So that also means, like, I've talked to people who developed for both Android and for iOS. And the consensus I've gathered is that yes, getting into iOS might be more difficult because you kind of need to learn a new programming language, but it's much more well documented and there's much more support because it's kind of structured in that sense. While Android programming is more kind of. That's what I've heard from people. I'm not big mobile programming anyway, but that is like the support and so on you get. But you might have a different opinion on this. But that's just what I heard from people. I've also heard negative things about iOS programming, by the way, so I'm not gonna tell you that's a big benefit anyway. Okay, so about the World Wide Web then. Business goals. Make the world smaller. Absolutely. I think that is one of the later business goals maybe because, well, maybe it's from the beginning as well. From the beginning, the World Wide Web was kind of communication between universities, I believe, or was it military? Anyways, US communication. That was kind of the internet in general, not the World Wide Web. But then they started posting information and so on, and it became an information network. Information should be free, kind of. But of course, they didn't in the beginning. They didn't think big in that sense. So in the beginning, it was IPv4 or IPv before that didn't have enough spaces for all the computers. So that's why we hired IPv6 to cover all the computers. So that is a little bit further than just the World Wide Web, but at least thinking about what the purpose was initially, it was just to communicate between universities and not between everyone in the entire world, right? And those business goals have evolved over time. Still, the whole idea of making the world smaller and information should be free is still kind of like a business goal. And you make money out of your content license, or things like that. But there are people in the EU Parliament who want to monopolize like certain parts of the internet and so on. And I'm not going to get into that, but so there are different business goals, but the way it affected the construction in the beginning, they thought small, and it had to change along the way. So you've seen here like a continuous evolving system. Of course, it evolves slowly, but it does evolve based on that. Okay. Just to, like, as an architect, having to have the mind, the first architect of the internet or the World Wide Web, like Winston Cerf and the people like that, to have the presence of mind to think like really big as an architect, like to state to the people there, let's make a system that can address billions of computers. Like at that point, like, are you crazy? There's only a market for 3 computers in the world, like the IBM statement or whatever. So why would we have billions of addresses or whatever? I think that is something we, as an architect, as a designer, having to think reasonable big, or having to think a little bit about the future, think ahead a little bit. And sometimes it's not worth it because you're short on money right now. You need to deliver the product now. So that is the design goal you have now. Like, I think that's more the case of Android, where, okay, iOS is getting shares. We need to, knock them down a peg, Let's develop something now that we can compete with. And of course, that has evolved as well. But I believe that you need to take those things into account as a designer or as an architect as well. Like, evaluate whether adding those features worth it, or deploying now is worth it. I mean, there are such design goals, and business goals, of course, has an important aspect into this. Okay, so to sum up, I have 2 minutes. Software architecture has a lot of influences in software engineering, of course. It affects almost every aspect of software engineering, like this software development lifecycle. And it's something that should go along together with the requirements and not just be one phase. And we learn things from previous development and from previous products. And I believe in either being faithful to the design, or updating the design as we start implementing. And I'm okay with like evolving designs and so on. And we can keep this design updated in various ways by doing stand-up meetings, doing a Scrum meeting, for instance. And the whole testing and analysis can be guided with this, with having a good architecture. You know what to test and when to test it. You can have these mock-up prototypes, so you know when to test things. And we can build into the architecture how we should evolve it. Based on the architecture, we can know the next step, how we can add features and so on. And we put equal focus on this understanding and both understand the process and the product, and how they fit together into making one, to create these business goals and make money, basically. Okay, any questions? Thank you for today, and I do hope to see you tomorrow during the guest lecture. That problem one will probably be shorter. I don't know. We'll see. Men sätt igång en grupp utan honom och så får ni lägga till honom sen.
Det har vi redan gjort. Men vi har skapat en grupp. Men vi kan inte lägga till någon. Eller jag kan inte lägga till någon.
Jag har aldrig använt den tiden, så jag har faktiskt ingen aning om det är någonting som jag ska göra. Har ni även funderat? Om det är någon annan som kan skapa det?
Vi kan skapa det. Men vi kan inte lägga till någon. Alltså, man lägger till folk när man skapar. När den är skapad så kan du lägga till någon.
Okay. I see. Maybe jag kan lägga till någon.
Då kan du lägga till.
Men i värsta fall så är det bara att...
Det är inget ställe.
Okej. Kan man skapa en till?
Ja, det borde man. Det kan vi. Ja, men det är ingen fara som sagt. Det är vi ställer internet igen. Det är bra. Försök inte.
Jag kan säkert...
Ja.
Jag
tror att det bara inte är någon som har rättigheter att sätta någon. Alltså att lägga till folk i gruppen. Det är ingen som är ledare för den gruppen som har skapat. Men samtidigt är det lite udda för jag kan ändra namnet.
Det är ju bättre än fronter.
Jo, men bättre än i vadå?
Alltså jag körde ju förra året så använde jag bara fronter som aldrig kan gå webben. Jag tänkte att nu har vi fått så canvas, man ska göra det bra.
Ja,
Igår var det istället det.
Ja, precis. Jag vet inte om det blir så mycket sämre vad gäller liksom, informationsspridningen. Jag menar, lampan finns fortfarande. Jag vet inte om det är någon
journalen ska vara på att se vilket.
annars får jag fungera så här.
Och jag är alldeles intresserad av det. Jag vet inte, han...
Bra!
Han säger, ja. Ja, alltså det är ju ett